Hi guys, welcome to the next lecture. Today I'm going to talk about the modulus function or the absolute value function. We'll talk about the graph transformations related to that. But first of all, let's focus on what exactly do we mean by modulus of x or the absolute value of x. Symbolically, this is the way we write it. You have two bars and inside you have a number which say at this moment is x. Now, modulus of x or the absolute value of x, how do you define it? Any real number x could be either greater than 0, it could be equal to 0, or it could be less than 0. So I'm going to define absolute value of x as a piecewise function. This is what you call a piecewise function when you put the domain piecewise and you have a functional value. In different domains, you have different functional values. That becomes a piecewise function. So when x is greater than 0, the absolute value of x is said to be just x. If x is equal to 0, then the absolute value of x is said to be 0. When x is less than 0, the absolute value of x is said to be minus of x. Now let's understand what exactly is absolute value for any number x. To find absolute value of any real number, you first locate that number on the real line. So suppose we're talking about x. X is here on the real line. Do you know what is absolute value of x? The absolute value of x is the distance of this number x from origin. The absolute value of x is defined as its distance from the origin. So, suppose you have, this is your number line. I've created it from -4 to 4. 0 lies here. Suppose I want to know what is the absolute value of 4. By the definition of piecewise, 4 is greater than 0. So what should be the absolute value? It should be just 4. Modulus of x when x is greater than 0 is just x. So 4 it is, right? What does it actually mean? It means that we're talking about the distance of this number 4 from the origin. Suppose now what I'm looking for is the absolute value of -4. Now, absolute value of -4, let's use the piecewise definition. -4 is less than 0. So it's going to be minus of x. So that means minus of -4. My x is -4 this time. Minus of -4 is just 4, right? So that's what, if you notice, is the distance between 0 and -4. The distance is 4 units, right? Whether it's centimeters or whichever unit we are taking in terms of number, then -4 and 0, the distance between them is 4 units. Now, which means that when you have these two bars for absolute value and whatever number is inside, these two bars or modulus, in other words, produces a number that is always positive. So always remember that modulus or the absolute value of any number is always positive. So what is the domain and range of this function? Suppose we take this function f as R to R. And fx is defined as mod x. By now, we know what exactly it means. It's a positive value that gets generated by any kind of input that you take. So that means domain for this function is the entire real numbers. Set of entire real numbers. You can have negative numbers, rationals, irrationals. All real numbers are possible as an input. And what comes out? I hope you understand the concept of range by now because we've discussed enough things in that regard. range for this function, that means a set of output. What kind of output is getting generated? Modulus of x is always giving you a positive number, including 0, because if it is the absolute value of 0, the distance of 0 from 0 is just 0. So absolute value of 0 is just 0, okay? Let's now talk about the graph of this function mod x, because we are well equipped with all the information that we require to create its graph. Mod x, if the input is 1, the output will be 1. If the input is 2, the output will be 2, because mod x, again, let's look at it piecewise. X greater than 0, it's going to be x. X equal to 0, it's going to be 0. X less than 0, it's going to be minus of x. That is why many a times modulus function is, instead of giving these 3 pieces, we take it as just just 2 pieces, and we take the distinction between greater than or equal to and strictly less than. So when x is greater than or equal to 0, it's just going to be x. When x is strictly less than 0, that is, it is a negative number, it's going to be minus of x. So when it is 3, when x is 3, input is 3, output is 3, input 4, output 4. So can you see the diagonal entries like this? Okay, 1, 1, 2, 2, 3, 3, so on and so forth. So if you graph, and yes, of course, at 0, the value is 0. So you'll have a point out here on the Cartesian plane. And it moves on and on like this. Now, what about the negative numbers? Suppose your input is -1. What's going to be your output? Will it be -1? No, it will be minus of -1, and that gives you +1. -2 input, output 2. -3 input, output 3. -4 input, output 4, and so on and so forth. So here for the negative numbers, it's going to be again a 45-degree line, but on the second quadrant. By now we do understand the quadrants as well, right? So always remember, modulus of x is a V-shaped graph. It's a V-shaped graph because you have a sudden change. In fact, in order to understand modulus of x, many a times we also try to understand x squared. So the graph is quite like x squared, except for the part of smoothness. This graph is not smooth. There is a sudden change. You know why I'm comparing it with x squared? For a simple reason. If you take square root of x squared, what comes out? If your answer is x, I'm going to give you a question here. Square root of -2 square. What do you think is square root of -2 square? I know that -2 square is 4. What is the square root of 4? Would you like to write it as 2 or -2? Of course, output that comes out of square root is positive. But I knew that the input here was -2. It was -2 square. So the correct answer is that we are taking the absolute value of -2. So square root of x square is modulus of x. You can foresee this function as the square root of x square. Any which ways, coming back to the graph, so the graph is quite like x square, but except for the thing that's a U shape, it's a V shape. V shape means there is no smoothness, there is a kink, there is a sudden change. That is what you should always keep in mind. Moving ahead, let's talk about some transformations here. So by now we know what is mod x. Are we prepared to talk about some transformations like what is mod of x minus a, x plus a, where a is some other number? Well, let's try to understand it, first of all, piecewise. So determine the definition for mod x minus 2 piecewise. Now, piecewise means that I want to break this up. In order to break this up, what I'm going to do is I'm going to first take the input behind these, input inside these two bars is x minus 2. When x minus 2 is equal to 0, that's my critical point where some change is happening in this function. So x equal to 2 is that critical point, which means that I'm going to define this function for x greater than or equal to 2 and for x less than 2. So when x is greater than or equal to 2, what comes out? Whatever is inside these two bars comes out as it is. That is, it's going to be x minus 2 as it is. But when x is less than 2, what comes out? The minus of x minus 2 comes out. That is why what do you get here is a piecewise function, which is the case for modulus always. Let's try to understand the same thing on a number line. So what did I just mention? I mentioned that 2 is a critical point here because the change is happening at 2. Why am I saying that? Because whatever is inside these two bars, modulus x minus 2, that is equal to 0 when x is equal to 2, right? So that is why I said 2 is the critical point. Now let's look at what happens to this function when x is lesser than 2, that is on this direction, and what happens when x is more than 2, okay? Because I said that the change, critical point means some change is happening in the function. So let's take x equals to 1 and analyze. Now x equals to 1, what is mod x minus 2? It's going to be mod of 1 minus 2. That means it's going to be mod minus 1. What is modulus of minus 1? Modulus of minus 1 is 1. How do you think you can get 1 when your input is x minus 2? X minus 2 in our case is 1 minus 2, which is giving you minus 1. If you will have a minus sign outside, only then you can generate 1, which means that if I will have a minus sign outside x minus 2, I am going to get minus of 1 minus 2, that is minus of minus 1, that is 1. Okay, I hope you're together at this. And that is why I mentioned that when x is less than 2, you will have to take the function as minus of x minus 2. Okay. Similarly, you could have taken any other value lesser than 2. Now let's take a value which is more than 2. Okay. Let's take the value 3. When x is equal to 3, consider mod x minus 2. That's going to be mod of 3 minus 2. That's going to be mod of 1, which will be just 1. Now, how am I getting 1? Well, if you just consider x minus 2 and your input is 3, 3 minus 2 is automatically giving you 1. You don't have to make any manipulations or any changes at all. You are just writing x minus 2, and that is why I said that when x is greater than or equal to 2, you will just get x minus 2. Always remember, this analysis that I've just given to you means if you have anything within these two bars that is modulus, anything it could be, when whatever is inside is greater than or equal to 0, the same thing comes out. When it is less than 0, negative of it comes out. If it would be the case of, say, mod of y minus 1, it's a different example altogether. If I'm taking y minus 1, then when y minus 1 is greater than or equal to 0, something happens. When y minus 1 is less than 0, something happens. y minus 1 greater than or equal to 0 means that y is greater than or equal to 1, and y minus 1 less than 0 means y is less than 1. I hope you understand number line. We've done it before. So when y minus 1 is greater than or equal to 0, we know whatever is inside comes out as it is. And when y minus 1 is less than 0, the negative of whatever is inside comes out. So which means that y minus 1 comes out when y is greater than or equal to 1. Minus of y minus 1 comes out when y is less than 1. And the same thing happened here. Great. So let's now move on to another example and try to do it. This time you are talking about 3 minus 2x modulus of that. Let's write it down piecewise. So first of all, I need my critical point. Critical point is when you put whatever is inside equals to 0. So that will give you 3 is equal to 2x, or in other words, x is equal to 3 by 2. So that means I can define mod 3 minus 2x as something when x is greater than or equal to 3 by 2 and something when x is less than 3 by 2. Well, let me take you to the number line first and then talk about it. In order to understand this better, let me again take you through the number line. So 3 by 2 is 1.5, which is between, right in the center of 1 and 2, right? Now let's take a number which is lesser than this, and let's take a number which is more than this. So let me take x equal to 1 and x equal to 2. So when x is equal to 1, it's lesser than 3 by 2. Let's concentrate on mod 3 minus 2x. That will just give me 3 minus 2. 3 minus 2 is 1. Modulus of 1 is just 1 itself. What has happened here is that I have not made any changes, and exactly whatever was the expression that was inside comes out. That means 3 minus 2x has come out as it is when x is less than 3 by 2. Yes, be careful with it. Now, this time, the same thing is coming out when x is less than 3 by 2. Why is that happening? Because notice you have 3 minus 2x. With the variable x, you have a negative sign. So everything opposite is happening. Now, when x is greater than 3 by 2, let's take the example that x is equal to 2. When x is equal to 2, you will have 3 minus 2 into 2. And that gives you mod of 3 minus 4. That's mod of minus 1, which is 1. Now, how will mod of minus 1 become 1? It will only happen when I will have a minus sign outside. So when you have x greater than or equal to 3 by 2, minus of 3 minus 2x comes out. Again, taking the same example, minus of 3 minus 2 into 2, that is minus of 3 minus 4 will give you minus of minus 1, and that's 1. So it's going to be minus of the expression that is inside. So you just have to be careful with what exactly is the expression in order to create your piecewise function out of it. Okay. Now we'll talk about these transformations graphically. So graphically, what does it mean? Your function is, and when x is greater than or equal to 3 by 2, it is minus of 3 minus 2x. When x is less than 3 by 2, it is 3 minus 2x. That is, whatever is inside comes out as it is. Let me now take certain values as we took. We took x equal to 1, x equal to 2. When x is equal to 1, fx is mod of 3 minus 2x, and hence I was getting just 1. And when x is equal to 2, fx is negative of 3 minus 2x, and hence I again got 1. So when I have to graph it, what's going to happen? When is this function 0? The functional value is 0 when x is 3/2. As mentioned before, this is equal to 0 when x is 3/2. So you will get 0 here. When x is 1, you're getting 1. When x is 2, again you're getting 1. When x is 0, when x is 0, you get 3. When x is 3, you get mod of -3, that is 3 again. So your graph will move something like this. It's going to be something of this sort. Okay. I'm going to mention here the values that I've taken. When x is 0, it's going to be 3. When x is 3, it's going to be mod of 3 minus 6, that is mod of -3, that is 3 again. So that's how this graph would move. Again, obviously, the function will be on the upper side of the x-axis because all the y values are positive. Let's look at some more transformations here. Y equals to modulus of x. We've already seen what the graph looks like. What about y equals to minus of modulus of x? What's going to happen? What kind of reflection are we getting here? Minus of mod x clearly is a reflection across the x-axis. Because if you look into it piecewise, this function is minus of mod x, and piecewise I can distinguish mod x as when x is greater than or equal to 0 and when x is less than 0. It's x as it is, it's minus of x. But now since you have a minus sign outside, it's going to be absolutely opposite. It's going to be minus x here when x is greater than or equal to 0. And it's going to be minus of minus x, that is x, when x is less than 0. If that is the scenario, then can you notice what's going to happen if I give it a positive input? If say I give it input 1, -1 comes out. Input 2, -2 comes out. If you give it a negative input, that is -1, -1 comes out. If you give it -2, -2 comes out. What you're going to notice here is that you will always just get a negative output coming out. That's because your function is nothing but a reflection across the x-axis. So it's going to be exactly the same graph, that is 45 degrees, 45-degree line here, and a 45-degree line here. But it's an inverted V instead of the V graph, okay? Similarly, you can now produce some more functions graphically, like, for example, we can take minus of mod x plus 5. This is another kind of transformation we can look into. Now here what's happening is that you have the reflection across the x-axis and then you're adding 5 to it. So let's see what happens to this. First, let's understand this function piecewise. So, well, it depends on x. Now, x could be greater than 0 or less than 0, right? Since it's not please remember, it's not modulus of x with 5. It is modulus of x with a negative sign plus 5, okay? So, dependence of modulus is only on x, okay? X could be greater than or equal to 0 or x could be less than 0. We just understood that minus of modulus of x will behave in the opposite manner. So outside the minus of modulus of x, this time you will have minus of x. Plus 5 stays as it is. When x is less than 0, minus of minus x gives you just x. So the function is x plus 5. So when you take a positive number, the function is minus x plus 5. And when you take a negative number, the function is x plus 5. So hence, what kind of values will get generated? First of all, let me take the value of x as 0. When x is 0, I'm just going to get 0 plus 5, that is 5. So the graph's going to be somewhere here. That's going to be on the y-axis when x is 0. When x is 1, y will be -1 plus 5. -1 plus 5 gives you 4. When x is -1, you will get -1 plus 5 again, which is 4. So that means it's going to be at 1, it's going to be 4. And -1 also, it's going to be 4. At 2, it's going to be 3. And at -2, again, it's going to be 3. So 3, right? If I take 5 as my input, I'm going to get -5 plus 5, that's 0. And when I will take input as -5, it's going to give me again -5 plus 5, 0, which means at -5 and 5, I'm going to reach here. And it's an inverted V again, but it's going to move something like this. So something of this sort will happen here, okay? And that's the transformation we've done with minus mod x. Of course, at home, I would like you to try out transformations like mod x plus 5 plus 10, or a general value, say c. What kind of graph can get generated? Please try that out. Thank you very much.